First off, let me introduce myself. I'm Adam Dawes. I'm a product manager on the identity team at Google. So the program talked about, oh, Dirk is here, about some cool technology that Dirk has been developing around how to harden authentication. We are doing something a little bit unconventional. We're going to do 2 half-hour slots instead of 1 hour-long slot. So Dirk will be doing the second half of the hour, and I will start the first half of the hour talking about account chooser and Google's, I'd say, journey with account choosers and trying to find a better way to do login with users. So this overlaps a bit with the presentation that Jack gave. Jack talked a lot about the best practices that a login system might want to do, and account chooser was a major theme of that, so there's definitely some overlap, but I promise that repetition will not spoil the prayer. Okay, so how did we, I think Google historically has had an authentication system like 99.99% of other sites, which was just username and password. And there's the big login box there that has all of those. I don't know, Eric has probably realized a long time ago that that was not ideal, but I think the evidence has grown over the years that there was a better way to actually build a login flow for users, and it's been a journey over the last several years, and we're not quite done yet, of redoing the way that Google's login flow works and trying to kind of get away from that username password box. So the first piece of evidence that really kind of struck home that, hey, this is not actually a one-size-fits-all kind of UX pattern was with our enterprise customers that used their own authentication, and we would be a SAML relying party to their authentication system. And so for the enterprise user, if they knew they were using Google Apps, and so they'd want to get to their Gmail or whatever, and so they knew it was hosted by Google, so they'd go to Google to try to get into their enterprise Gmail. And they get to a login screen like this, and they would type in their username, but they don't have a Google password. What are they supposed to do? Because they log into Google via their own enterprise IDP. So we called this the password box, kind of the idiot box, not very charitably, I would say, but because what most enterprise users would do is be like, yeah, my enterprise uses Google, so let me just put in my enterprise password in here, which is exactly the last thing that enterprise's security team, their IT team, wants them to do. They don't want that user to be sharing their password with other sites, allowing people to hack into those accounts, but that's exactly what many of those users were doing. So we've since changed it, but we had a little dialogue when we saw that password box had been filled in, which was sort of like, please don't do this. All you need to do is type in your email address and we will redirect you to your SAML IDP. So that was sort of the first case of where we recognized that the common UX paradigm was not great. Another one that we identified was the new user sign-up case was not always the smoothest process for a user, and the reason why it wasn't always smooth was because they actually already had an account. And this can kind of work out in 2 ways. One way would be if they were registering for an account and not signing up for Gmail, they were signing up with a Yahoo address or signing up with a work or a school address or something like that, we could actually be a little bit more helpful to them, saying, hey, you know, that Yahoo account already exists in the system, and if that's your Yahoo account, you'd go, oh, duh, I already signed up somehow. But if you actually had signed up for a Gmail account and you kind of forgot it, then that was, you know, oh, what do I do? And it was not actually a thing that we could help disambiguate, and so we'd get a lot of additional accounts that were created because of that. So that's not good for the user, that's not good for Google. So it's much better to try to see if we can get the user on a path of reusing the account that they have and putting more, using that identity more. The more they use that identity, the more useful that identity will be for them. So again, I've sort of been saying that this is kind of the tried and true auth UX, where we have the username, the password box, and I think everybody kind of assumes that this is the way it's supposed to be, that, you know, this is authentication and it's viewed as sort of a single act, and, you know, let's just get on with it. We all do this, you know, a handful of times every day. We're kind of inured to this process and the pain that, the friction that it involves as we go through to get to the sites and the data that we're actually interested in using. But if we take this and we break this down, we actually have the identifier and the credential, which are two separate things. And if we separate this act, and if we, to use a different analogy, if we pull the chocolate and the peanut butter apart, you know, those two things actually have a lot of value in and of themselves. You can like chocolate by itself, and it doesn't have to be a Reese's peanut butter cup all the time. So when we started to think, okay, well, what if we separate these two things? What might get better if we try to first understand what the identifier is for the user and then try to figure out what the authentication path should be? This is one of the messages that Jack talked a lot about. So one of the first things was it solves this kind of idiot box problem for the enterprise users. So if we find out what the email address is, then we can immediately direct them to their SAML enterprise authentication endpoint. And if we, if that endpoint actually uses like OpenID Connect and operates and configures itself nicely, then you can actually pre-fill that identifier into the login box. That hint that you gave to Google, we can pass that hint on to the enterprise IDP, and you've now not required, you've reduced that friction significantly for that user to log in. And that's great, particularly on a mobile device. And then we also have this same issue because Google is actually a relying party to other large internet services. So we have a federation for accounts from Yahoo, Microsoft, and AOL. If you have identities from those IDPs and you create a Google account with those identities, you can actually use those IDPs to log in instead of creating a password on Google. So this flow gets better for those IDPs, and when we, again, kind of move our major UX in this direction, then that actually opens up the opportunity for us to be a relying party to potentially more IDPs. So, you know, mail.ru and you know, large regional IDPs, you know, mail providers, we might want to start to become relying parties to them if they start using standards for federation and such. So that's a good thing for security, a good thing for those users, and a good thing for Google. So it's kind of a win-win across all sides. So it's great for federation. Another thing that we understood and we've realized is more and more important over time is that it's good to be able to present different kinds of login challenges. So, you know, two-factor has become very popular over the last couple of years. So that's a different kind of login flow. It usually starts with a password. But there's a lot of experimentation at Google and I think across the industry about what that login flow could entail instead of a password. Nobody likes passwords. There are a lot of negative properties around passwords. And we believe at Google, and I think others do as well, that by diversifying the set of credentials that a user can use, we can, you know, we can move the frontier of both increasing security as well as increasing usability through that authentication process. So when you have the hint of the password, you can then bring up the appropriate authentication mechanism, the appropriate challenge for that particular user. And this might be because the user is registered, we know what their mobile phone is, they may have set up for two-factor authentication, so it could be based on what the user has already set up with us as an identity provider. But it also gives us tremendous flexibility from a risk perspective. So, you know, we are long beyond the time where just having your identifier and the appropriate credential is what is sufficient to get you into a Google account. There's a lot of smarts behind the authentication event that looks at additional signals of location and patterns and usages on those machines and all sorts of factors that we use to determine how likely it really is that the user that we think it is actually trying to authenticate. So again, when you break apart the authentication into identifier and credential, that allows us to throw all of that risk analysis in to determine what the appropriate authentication credential should be or the appropriate challenge should be for that user. So what does the UX look like when you do this separation? So Jack showed this as well in the GitKit presentation, but it's pretty simple. It's just, you know, at its root, the user just needs to type in their email address. It looks a little bit spare, I have to say, at least to my eyes, because I've seen the username password box so many tens of thousands of times. So I think you know, people feel like maybe from a UX standpoint, this is perhaps a little bit awkward. It's unusual. Will users get it and understand what's going to happen through the process next, since everybody is so well trained on username and passwords? You know, we've done some research. We don't have anything to indicate that this isn't going to work just fine for users, but in terms of getting folks to sites and apps to adopt it, it feels like a little bit strange. It's a new way of doing things.
Many sites it's saying, where do I enter my password?
Exactly.
You help the user by saying, give it later.
Yeah, they are used to this authentication ritual being all wrapped together, and so when you change the what the ritual is, people get a little bit uncomfortable, perhaps. But we haven't actually seen anything to that effect. But I think that's just sort of a reaction that we see from some folks. But what we can do to improve the situation is start to remember what the identifiers are on the machine that the user is using. So this checkbox here allows the site or us to store in a cookie, you know, the fact that this identifier has been used on this cookie on this device before. So that actually changes things quite dramatically from a UX standpoint. So when we've saved that identifier on the device, and the next time the user tries to log in, we can actually give them an extremely personalized view. And we've found that the reaction to this is very positive, you know, from users, that this actually increases the sign-in success rate because the user is able to immediately identify that this is their account, particularly if they've gone ahead and actually saved a profile picture. I think this has been one of our surprises over time as we've done all this UX research on login flows and identity, that this paradigm of actually having your profile photo tremendously helps the process. It engages the user, that familiarizes and orients them to what's going on, and so it's a pattern that we have are using, you know, very widely across Google and only continuing to do so further. And then another huge benefit to remembering what identifier was used was that you don't actually have to type the email address ever. That just is already there. might not actually seem like a big deal, but when you're worried about conversion rates and in terms of sign-in success rate, this is actually something that moves the needle a little bit. And I think everybody here can appreciate that not having to do that on a mobile phone is a huge win. Like, we've all bailed on many, wanted to do something on a mobile phone and bailed on it when we've gotten to the login screen. And so saving the account, that actually helps the UX tremendously. But at Google, we have millions of users, tens of millions of users that have multiple Google accounts. How many people here have multiple Google accounts? Yeah, I'd say 80% of everybody. So how do you treat, if you're only storing that single account that had logged into the device, what do you do when you're switching around to different identities? Do you just use the last one, or what have you? So that clearly was not the best answer. So what we've done is we've created our own account chooser. So what we do is whenever a new identity is used in a browser or on a device, we remember that account successfully logged in. And then the next time you go through the login process, then you're actually able to see a menu of all of the relevant accounts that you might want to actually use. This is actually not totally simple and straightforward logic. We have to take into account public machines where you have lots of random users that might be logging into a given machine, and so we actually have to try to identify those sorts of machines and not save the information when that's the case. But when we get into this account chooser UX, we find that this really simplifies the multi-login situation. Google also supports multi-login, where you can be logged into Gmail in 2 different accounts at the same time. You don't have to log out and then log back in as that second user. You can be logged into both simultaneously. So with that feature, getting the user to sign in and to sort of disambiguate which identities they're using and which identities they're trying to log into is really helpful. So that's actually been a big win for us as well. And then another context which this is very useful is in OAuth consent flows. So we found that if you are about to share, say, your contacts with, say, LinkedIn, then this kind of account chooser paradigm can work very well for the user to select, I want to give my personal contacts to LinkedIn and not my corporate contacts. And that's very clear as they go through this account chooser flow. Another thing, once we got into the consent flow and once we started to use this account chooser, we and Federated and other sites were using Google as an identity provider for login, we noticed that we had this issue of double consent. So you'd go to a site like, say, SlideRocket, and you'd hit that Google button to log into SlideRocket. Google would then bounce you to an account chooser to say, which account do you want to log into SlideRocket with? Great, that's easy. So I click on that identity that I want to use. And then what we had done was ask for consent to give SlideRocket back your email address. Well, SlideRocket, going through this account chooser process, you had very clearly indicated which identity you wanted to give SlideRocket. Your whole intent of going through this flow is to log into SlideRocket with the identity that you click. And so when we did user research studies, one of the main pieces of feedback that we got was, what is this for? Why are you asking me to do this? I mean, first, the consent page is not the friendliest thing to begin with. You kind of have to read it and like, it's a little bit scary. And it's really just reinforcing act that was implicitly done on the account chooser page. So what we've done is to not show the consent page in cases where the relying party has already given us a hint for what user wants to log in. So all we're doing is verifying that that user is logged in and present on that device in that browser. And if that user is logged in, we say, yep, it's okay. And the user doesn't need to go through any of this additional friction with the consent page. And once we sort of set up this model of being able to provide a hint to Google and then get an identity token back without any consent, that opens up a number of new possibilities as well, where the user can, or the site can, do verification of things like their email address without any user interaction. So if you're able to capture the user's email address on your site and you have some indication that the user might be a Google user or logged into Google, then you can query in the background and get verification that, yes, that Google is there and logged in at that moment. And you're able to do things like bypass email verifications that you might otherwise send for a new account creation or what have you. One concern that we had a little bit internally around using this account chooser paradigm and login flows in general was, what should the branding be? There's, the kind of knee-jerk reaction is that for the login, you'd need to have strong branding for the user to understand what flow that goes through. What we found with YouTube is that that's actually not really the case. Our research shows us that something like 50% of YouTube users actually have no idea that Google owns YouTube. So for them, these are totally unaffiliated brands. Yet the flow to log into YouTube requires a Google account, and so they go through this flow. So they, first click on the sign-in button in the upper right-hand corner of YouTube, and that takes them to the Google-branded account chooser, and they can click on that, and if they're and go through that process, and then they're automatically logged in. So you'll see that brand-wise, you go YouTube, Google, YouTube, and our research shows that that actually has not been any kind of issue with users. So we have this, we've found stronger and stronger signals that this account chooser paradigm actually has a tremendous number of benefits for us, and we have implemented our own kind of local account chooser to help us with a lot of these problems. But wouldn't it be great if all sites could go through this login flow and this process of saving the accounts that are used on that machine, and then letting any site reuse that list to help bootstrap the login flow to do all of the things that I've showed that we're doing. So such a thing does exist, in fact, exist. We've been very actively working with the OpenID Foundation and the Account Chooser Working Group, whose mission it is to have a completely open and available account chooser that any site can use on the internet. And once again, a lot of people, when they initially see account chooser, they think that all of these things are being stored in the cloud someplace and that somebody's going to correlate all of my different identities, and they get kind of freaked out. That's completely not the case. We've worked very, very hard to design the way that account chooser works so that it is completely privacy preserving for the individual. Account chooser sort of collects, like breadcrumbs, the different identities you've used on your internet travels, and then is able, and it stores those different identities locally on your machine. So it's really just another form of a cookie that's left on that machine, and you can go and erase it at any time. And no site, Google, Account Chooser, OpenID Foundation, anyone is able to actually look in and see what those values are inside Account Chooser. So it is very privacy preserving. It's easy for developers to integrate. They basically need to set up one endpoint to retrieve hints back from the account chooser to bootstrap the flow. And they need to rejigger their UI a little bit to introduce account chooser as a part of the login flow as opposed to their kind of staid username, password, and NASCAR system. But is quite straightforward to do. So as of this week, Google is now bootstrapping the account chooser, the accountchooser.com account chooser. So one of the challenges accountchooser.com has been that a lot of people think that this is an interesting flow. They'd like to experiment with it, but it doesn't really provide much value until there are identities that are stored locally on people's machines everywhere. So how do you get that bootstrapping process going? So Google is now highly committed and involved in bootstrapping everybody's machines out there by allowing the identities in your Google account chooser to get pulled into accountchooser.com's local storage on your machine when you go to a site that uses account chooser. And as we move forward on our own journey, we will actually be doing more and more with accountchooser.com, and ultimately we would like to be using accountchooser.com as our account chooser as opposed to the one that we have actually created. So it's not just Google that is using this account chooser model for login. We're seeing that this is starting to take off and that a lot of other large providers are using this login flow as a way to ease users into their apps and into their sites and get the higher conversion rate. So the Android OS now provides an API that allows users to bring up an account chooser to bootstrap the account chooser flow. And this at the present time only works for Google accounts that are on the phone, but we're looking at ways to expand that to hold all other identities. And I just noticed the other day that when I was using the Yahoo app on my Android device, that they basically have also adopted this account chooser. They have users that have multiple accounts as well, and so they're using this account chooser paradigm to help add and switch different accounts. We can also see that Apple is taking a look at the account chooser model. If you go onto Apple TV, you'll all apps on the Apple TV have to go through the Apple authentication flow. It's just a part of the way that authentication is done on that device so that users have a common UI for how they do it. But one of the features of that tool is that they have a recent identities tab where users, if they've gone through the trouble of typing in one of their email addresses for one app, then they can reuse that. They don't have to go through the pain of actually retyping for the next app that they try to sign in with. So lastly, I've, I think, shown you a bit of the complexity that can be involved in the flows when you introduce an account chooser. And really, I think the message here is that there's a potential great deal of complexity that you can introduce by having an account chooser. But really, you only need to wade in. There are a lot of advantages that can be realized very quickly and easily once you introduce an account chooser. And you know, we've gone through many hours of work trying to figure out what the best login flow is going to look like. And I think what Jack highlighted through the GitKit presentation is what we feel is going to yield the highest success. And one of the benefits of using tools like GitKit is you get all of this complexity done and figured out for you and implemented for you. But there's still a lot that you can do to gain from using an account chooser without taking on all of this complexity. And you can chip away more and more to increase your conversion rates over time. And if you'd like more information about how to use accountchooser.com, you should go to accountchooser.net, and that has all the details on the APIs and how you would actually integrate onto your site. And that's it. Any questions?
Does that make account chooser an IDP, or
It's just a cookie. It's a cookie that it's a cookie and a program that will then provide back identity hints to these sites that integrate with it.
Just text me. Just text me. No sign of certificate. No sort of security there.
We've looked at it very, very closely from a security standpoint. Yep. So I don't want to take too many questions because I don't want to get into Dirk's time, but I'm happy to talk after the session if you have more questions. Thank you.
Now, where am I here?
Hey, Adam, do you want to show Dirk where it's? Oh, sorry.
All right. Can we get any more full screen than this? All right. Hi, I'm Dirk. Last half hour of the day, I think, right? All right. So for the last half hour of the day, I think we're going to be switching gears a little bit. You've been hearing a lot about sort of the user experience around passwords and how to make them better with federation and so forth. And I want to maybe come from a slightly different angle, which is the angle of security and what's wrong with security of passwords. And in fact, not just security of passwords, but security of bearer tokens in general. And you'll hear in a moment what that is. This can get sort of technical. We'll talk about cryptography and so forth, but I think I'm going to try and keep it fairly high level. And in particular, you'll see that the talk is a lot about how to try to get what seem to be simple ideas, although albeit some technical ideas with cryptography and what happens when they sort of collide with reality and how do you do things in practice. So bearer tokens, right? So bearer tokens are basically what we use today to authenticate on the web. And we call them bearer tokens because the way they're used is I come bearing the token to the website. And so I have to carry my password, carry, right? I carry my password to the website, and I show the way I prove to you that I know what the password is I come carrying the password and I show it to you, right? That's how we do authentication on the web. And password is just one example of such bearer tokens. Authentication cookies work exactly the same way. The way my browser proves to a website that it knows the value of a certain cookie that was set, it takes the cookie and carries it to the web server and shows them, look, here's the cookie, I had it, now I carried it all the way to you, and now I've shown it to you. And doing things that way, using bearer tokens, both in terms of passwords and in terms of cookies, opens up doors for attackers to steal these things. And there's a whole bunch of different ways they can be stolen. Like in passwords, we're probably most familiar with these things. If I accidentally take my password and I carry it to the wrong person, that's called phishing. I just gave my password to somebody that I shouldn't have given it to. And because we use passwords like bearer tokens, that person that I just carried my password to can now take the password and they can carry it to the original website, and now they're logged in. Password sharing works the same way because I have to take my password and give it to different websites because just like anybody else, I can't remember 200 different passwords, so I take the same password and I give it to different websites. Someone who breaks into one of these websites can take the password and can carry it someplace else. Some of these other attacks, and those two don't tend to apply to cookies, but some of these other attacks also apply to cookies, and they work because cookies are bearer tokens as well. Network attacks, for example. the DG Notar incidents that we see in the world, the beast attacks, the heartbleed attacks, and so forth. Places where, despite the fact that TLS exists and supposed to encrypt things on the wire and supposed to make things unaccessible to attackers, every now and then stuff happens and it becomes accessible to attackers, and they can reach into the network. They can take the password, they can take the cookie, and they can take them someplace else, into their lair, or wherever the bad guys are hiding, and then they can play them from over there. Then there's client compromise, server compromise. If you break into my laptop, and you can put a keylogger on, you can see what my password is. You can go through my cookie jar, you can see what my cookies are. On the server side, if you break into the server, you see all the passwords arriving there. You see all the cookies arriving there because we're using bearer tokens. So lots of different avenues for the bad guys to get to these things, steal them, take them home, use them from there to break into my account. Now, why are we doing this, right? We know that fairly simple challenge response-based protocols should put a stop to this. If we just use public key cryptography, you send a challenge to the client does something behind its back with its private key without ever showing you what the private key is, shows you the response, and the server can verify the response and now knows, yes, the client is in possession of these credentials. No, they didn't show me the credentials. The credentials were not sent across the net, and authentication should work that way. So that's great, right? So why aren't we doing that? Well, there's a version of software that can do this, deployed on pretty much every machine out there. It's called TLS Client Authentication. It's built into every browser, every TLS library. That works exactly that way, that does challenge response, public key based authentication. So in theory, that should work fairly well, but in practice, nobody's using it. There's a few enterprise deployments that use it, but on the web as a whole, it's non-existent. And there's a bunch of reasons that have to do with some technical issues with TLS, have to do with the user experience that tends to come with TLS client authentication. Don't want to get too much into the details of this. Just want to say that just pointing to a technical solution, say, look here, my client can do public key challenge response-based authentication, that's not the end of the story. If that were the end of the story, we would be doing it today because all our clients have software built in that have the capabilities. So some of the projects I've been working on is sort of sitting down and thinking through, okay, how should we do this? How can we bring crypto back into the equation here on the web without having to boil the ocean, without having to rewrite all the applications, without telling developers out there cookies is no longer how we do things. So that's probably infeasible. But on the other hand, we do want the benefits of having a challenge response type protocol. So I'll be talking the remaining 22 minutes. I'll be talking about two of these sort of projects I've been working on. One deals with cookies, the bearer tokenness of cookies, and one with passwords. And in the cookies case, I'll be talking about something called channel ID and how we can channel bind cookies and how to sort of de-bearer tokenize them. And on the password side, I'm going to be talking about a JavaScript API for identity assertions, which can be used to de-bearer tokenize. I'm inventing this word, de-bearer tokenize passwords. All right, so let's start with cookies and this thing called channel ID. So channel ID is an idea where we say, well, during a TLS handshake, why doesn't the client just today, during pretty much every TLS handshake, the server proves possession of a certain key pair to the client. That's how we know that when you're logging into Google, that you're really logging into Google, not somebody else. If you're logging to Facebook and so forth. Clients, on the other hand, don't tend to do that. This client authentication thing I talked about is an ability for clients to do that, but it's rarely turned on. So what if we say, well, let's turn it on. Let's do that. Let's do it for every TLS handshake. The client is going to prove possession of a certain key pair. And let's do away with all the UI that normally comes with the stuff. The client is just going to do this under the hood. And let's sort of rethink how that is done. Let's not send public keys in the clear because that's a privacy issue. That's sort of like sending user IDs in the clear. So we're not going to do that. Let's use different keys. Let's guarantee that the client uses different keys for different servers, which is another privacy thing that TLS client authentication doesn't take care of. And there's a couple of other sort of technical details, but basically it says, well, let's just do client authentication on every TLS handshake. Whenever my client connects to a server, it will also, as part of the TLS handshake, it will say, by the way, I'm in possession of the following key pair, and here's a proof that I'm really in possession of this key pair. You sign something like the hash of the handshake messages or something like that. And so then the server knows, oh, I'm talking to somebody who's in possession of the following key pair, and the public key of the key pair is this. And I just saw a proof that they control the corresponding private key. And that public key that falls out, we call that the channel ID of the TLS connection. It's something that remains constant across different connections. The same client, when it reconnects to the server, will present the same channel ID. And now what we can do when that happens, we can what we call channel bind cookies to that channel ID. Right? Today, when a server sets a cookie on a browser, like a login cookie after I check your password, that cookie tends to be either a pointer into a database where it says, you know, this is Bob or this is Alice or something like that. Or the cookie itself might be some encrypted data structure where in the data structure it says this is Bob, this is Alice. And there's some other parameters usually in there, like this cookie expires 2 weeks from now, or you know, there's stuff in there. And so let's just add a little bit more stuff into that data structure that the cookie represents and say, well, this cookie better be sent to the server over a TLS channel that has the following channel ID. Right? It's just another, like in this little picture here, I just say, well, normally we have the user ID in there. Let's just add one more thing in there, which is this public key that the client proves possession of. So now when the cookie gets stolen, right, the next DigiNotar incident happens, somebody gets in possession of a certificate that allows them to look like Google or Facebook or something to clients in certain countries, and they actually can terminate TLS connections, they can get to the cookies, they can try to steal the cookies. If they then try to send the cookies from a new TLS connection, the cookie will say, well, I need to be sent over a TLS connection that is authenticated with a certain key pair. And because the man in the middle, they were just in the network. They weren't actually on the client where they had maybe access to that private key. So all they have is the cookie. And when they make a new TLS connection to the server and send the cookie, there's a mismatch. The cookie comes over a connection that it shouldn't be sent over, and the server can detect that. So if we do that, right, we're starting to make a dent into our picture here, right? If I now have a network attack and I send a cookie and I'm able to reach into the network and get the cookie out, we're protecting users at that point. Similar, if I have a server compromise, I somehow manage to break into the server, I see all the cookies arriving. If I want to sort of load up my truck and drive away with the cookies and use them from someplace else, I won't be able to do that. And I should add a little caveat here is that a server compromise, even in that world, would still be a very, very bad thing, right? Someone who breaks into a server can do a lot of bad things. One thing that they cannot do at that point is load up a truck with cookies and drive away and use them from someplace else. That's what that little heart means. It doesn't mean that server compromise all of a sudden is something we don't need to care about anymore. All right. So I said I'm going to talk about, how simple ideas like that sort of tend to collide with reality, right? So we went ahead and implemented this in Chrome on the client side and on the server fleet on the other side. And we tried to roll this out and said, let's channel bind all the cookies. And it turns out it's actually harder than you'd think. If you have a bug in your client software, which ships once every 6 weeks, I think, you don't get to move very fast, right? You say, oh, darn, we forgot to add the channel ID feature in this sort of edge case when you come over a certain network or something. And then you fix the bug, and then you realize, oh, actually, no, that wasn't quite the fix. We need to wait another 6 weeks. And so you kind of move slowly. That's one lesson we learned. Another lesson is that there are these enterprise proxies that, I want to say for legitimate reasons, terminate TLS connections and then reestablish them to the outside world. And so if you're sitting behind one of those enterprise proxies and you've gotten your cookie set on the browser while you were not behind one of these, it'll look to us like there's a man in the middle. One could argue there is a man in the middle there, but it will certainly look to us like there's a man in the middle there. So that happens every now and then, and we need to deal with this, right? So the status at this point is that it's implemented in Chrome. At Google, also, we have started to channel bind some of the cookies, mostly our own internal traffic, and we're looking to roll this out carefully because of these issues to the general population. Yeah, there's a man in the middle there because, so, oh, sorry. So, right, so let's say I'm at home. I had a TLS, an uninterrupted TLS connection to Google, which has a certain channel ID. Cookie is set. Cookie says, I need to be sent over a TLS channel with fingerprint 1, 2, 3, 4, 5, right? So now I go to work where I'm behind one of these proxies. When I establish a connection to the proxy with that channel ID, but the proxy doesn't have my public key. So when it turns around and opens a connection to Google, the channel ID there will be different, but the cookie will be sent over that channel. All right, so now passwords. Like cookies, passwords are also bearer tokens today. They're sent, well, not in the clear because usually over TLS, but they're sent unmodified from the client to the server. Wouldn't it be a better way if instead of having these HTML forms that I type my password into and then send them to the server, if the login page looks something like this? I can make a JavaScript call that says, hey, browser, can you check that the user is there? And then the browser responds at some point and says, yep, I checked the user is here, and here's some proof that the user is there. And it's that proof that you get in the callback that you, instead of the password, send to the server, right? And so that proof should have sort of interesting properties, right? It should have the property that if I accidentally send it to the wrong thing, if I accidentally send that proof to a fisher, or accidentally send that proof to a man in the middle, if they then turn around and try to send it to the real server, it should break. It should not work, right? That's different from how passwords work. Passwords, if I send them along, the server doesn't know the difference. It's just the same password. So what is a proof like that? What does it look like that has this property? Well, it looks something like this. It's a signed statement that says, yeah, I promised the users here. And the challenge that the server sent was, I don't know, 1, 2, 3, 4, 5 or something. The server better check that that was really a challenge they issued in the last 5 minutes or so. The signed statement also says, you know, when the JavaScript made that call and said, hey, browser, can you check that the user is here? That JavaScript ran on accounts at google.com, on login at facebook.com, or whatever the origin is, right? And that's how you get rid of the phishing problem, right? If I accidentally point my browser to fisher.com instead of google.com, and fisher.com makes that JavaScript call, the assertion will say, fisher.com made that call. And then when fisher.com tries to turn around and send this thing to Google, the computers are better than humans at figuring out that fisher.com is not the same as google.com, and that shouldn't be, one shouldn't be mistaken for the other. And then the last thing in there is that channel ID thing, again, that I just talked about in the context of cookies. That makes sure that this whole signed statement, as it travels through the network, if there is someone who terminates TLS connections in the network, it stops working, because the second leg of that connection will have a different channel ID. And so this is signed by what? Well, it's signed by some sort of key that the user is in control of and that is already known a priori by the server. We're using internally, I should have brought some of these, little USB tokens that we give employees that look a lot like this thing here, that sort of disappear in your USB slot, that have a secure element in them. There you go. Thank you. Looks like this.
You can see that back there, right?
It's pretty small. It fits into your USB slot, basically. Or you could imagine maybe it's actually in your phone. Maybe, sorry. In your phone, maybe there's a secure element in your phone, or maybe in TrustZone or something like that. All right. And so you can see if you use that proof either instead of your password or even just in addition to your password, right? You de-bearer tokenize your password. Because even if you use it in addition to your password as a second factor, if that second factor breaks because it came from a phishing site, because it came from a man in the middle, you don't allow the login. So what's the current? I said a little bit about where we are with the cookies and the cookie binding. What's the status of this? I ran over here from a talk from the other room. I apologize to everybody who saw me over there because there's a bit of overlap. there's a standardization organization called FIDO that is in the process of standardizing these protocols that have to do with the JavaScript APIs. And it's not just JavaScript. If you're talking Android or iOS or something, then you're not talking JavaScript. You're talking Android API, iOS API, and so forth. Those APIs, they would have to be baked into the browser in the case of JavaScript. They would have to be baked into Android in the case of Android, and so forth. We're not quite there yet. If you want to try this today, and this is what we do internally at Google, for example, you need to install a Chrome extension that makes it look like this browser has the browser has the JavaScript API. But thankfully, Chrome extensions have the ability to speak USB, so that's all you need to install. You install a Chrome extension, and then you're ready to go. All right, so now our picture is starting to look a lot better. There is the phishing is taken care of for the passwords. Password sharing is no longer a problem because instead of passwords, or at least in addition of passwords, you have these public keys on file. You're showing me this the time, 5 minutes? OK, 5 minutes? All right. The one thing where there's still devils here, right, is the client compromise. And that sort of depends on how this is implemented on the client side. If I have one of these USB tokens that Eric was just showing, which has a secure element in it, we can be fairly certain that malware can't extract that private key out of that thing, right? But if it's all implemented in software, then if I have all these other things are still nice, right? I'm still protected against network attack, phishing, and all that stuff, right? But if I do have a client compromise and I have my private keys in software, they will, they're vulnerable to theft at that point. So therefore, that's why I have both of these. All right. I don't know why she said 5 minutes. I thought it's 8. All right. So this is sort of the technical part of the talk, right? So the cookies, at this point, I hope you understand how by using channel ID and channel binding cookies, we can de-baratokenize cookies. And by replacing or amending passwords with these identity assertions, we can de-baratokenize passwords. So now, what are some of these real-world challenges that happen when you try to roll this out? So one is that there's sort of this balancing act between privacy and security that you end up having to do. You want to make sure when you introduce channel ID where the browser has a key pair that approves possession of every time it connects to a server, you don't invent some new super cookie or something that can be used for tracking, right? So how do you do that? There's the UI issues involved. How do we explain to the user that this is happening? How can they wipe these things? How can they make sure? They need to be in control of these things roughly at the same order that they're currently in control of cookies, right? And there's one particular thing I want to talk about, which is third-party connections. In Chrome, there's a feature where you can turn on, you can turn on a feature that stops sending cookies to third-party through third-party connections. Safari has this thing on by default. And the way this is implemented is if you look at a website like this, is the New York Times. Up here is an ad. That's a third-party connection. It doesn't go to New York Times. It goes to some other server. Is that somewhere in the layer, network stack layer, there's the HTTP layer. And the HTTP layer needs to be aware of the setting. If the user doesn't want cookies to be sent to third parties, the HTTP layer better know about this and not send the cookie, in this case, to Ads or Us, where it's fine to send the cookie to New York Times because that's a first-party connection. So now when you introduce channel ID, presumably the user has that same expectation. If they select that feature, or if they use Safari, which has this feature turned on by default, the user expectation presumably is that third parties are not able to track the user, right? But what that means is that now a different layer in the stack, the TLS layer, needs to know about this setting and needs to, when it connects to the New York Times, use channel ID, and when it talks to Ads or Us, not use channel ID. And it turns out that's a bit of an engineering challenge to all of a sudden have two types of TLS connections in the browser, when before you only had one kind of TLS connection. So that's the kind of stuff you tend to run into. Similarly, again, security, privacy, balancing with these little crypto token, the USB tokens we have, you run into similar issues. You don't want to build something that becomes a potential tracking mechanism for websites out there. And again, there's a bunch of different sort of facets to the problem. One thing that I kind of find interesting is how do you do attestation? You want to be able to prove, you want to say, look, I am a particular token that was made by this particular manufacturer and has these security properties. And here's an attestation certificate that sort of shows that, yes, I'm one of these tokens. But how do you do that in a way without saying, I'm token number 1, 2, 3, 4, 5? In the current version of the protocol, we say, well, you need to make a batch of at least 10,000 tokens, and they all have to have the same key burned in. That's not great, because now when I actually go and take my asset in my file to one of these tokens, and I am able to retrieve the private key, I just retrieve the private key of that token, and it's 9,999 brethrens, right? Which all need to be revoked at this point. That's not great. So we would like to have sort of the best of both worlds. We would like to have different secrets in each of these tokens, but not have an identifier that pops out of this attestation flow. So there's interesting crypto work that we can do that comes up with protocols that allow you to do this. Legacy. Adam, I guess you didn't touch on this that much, but one of the things when we moved from passwords to OTPs was there were lots of legacy applications out there that had built in, hard-coded the assumption that the way the user logs in is with a password. And then we managed to say, to convince the people who made these legacy applications, and yes, that includes our own Android, to say, hey, can you guys be more flexible about this, please? Why don't you just show a web view? And then some users will just need a password, but some users are going to see another web page after they type their password. And now if we want to move to these account user flows, maybe they don't even see the password on the first page. Maybe they might see it on the second page and so forth. So it's great, right? Now we're all sort of high-fiving each other. But at that point, we're at the place where now there's this new JavaScript API that we're assuming is available. But it's not. It's not there in the web view, right? So now we're back into sort of a legacy world where we have to think about legacy clients. I'm going to skip over the standardization problem and maybe finish with this part. The two devils that remain in my picture here are in the client compromise, right? If I'm forced to use these to create these keys and software on the client side, there's always a danger that when I infect myself with malware, someone can steal the cookie and the private key, and now they're in the same situation they were before, or steal the password and the private key, and now they're in the same situation they were before, where they have stolen my credentials, right? And it's surprisingly hard to be able to access secure hardware on client platforms, be it on laptops or phones and so forth. I would like to see faster, secure elements on these client platforms that are openly accessible to developers. That would get rid of that sort of last remaining column there. All right. I hope I didn't make anyone upset about running over. By my calculation, we still have 2 minutes. So if anyone has a question, maybe we have time for one question. OK. So I am not a lawyer. If you talk to the people at FIDO who understand this licensing stuff, which I'm not one of them, I think they will tell you that you shouldn't worry, and that it's all good. That's what I heard them say. So fine, they're here. I saw them walking the floors. Talk to them. I don't know the answer to your question. Oh, I see. So the channel ID stuff is something that we're trying to do through the ITF. The password identity assertion, that is the FIDO work. I was describing the FIDO work. I'm not sure whether the word FIDO was anywhere on the slides, but that's what it was.
So we have to wrap because they need this room for tonight's events. But thank you very much, Dirk.